This video shows a brief example of the modelling techniques used to develop the performance of aircraft engine fan blade assemblies and search for vibration characteristics. Exposed to high rotational speed, aerodynamic pressure loading and temperature, the fan set experiences significant stresses and displacement during operation. It's important that these are assessed within design to ensure accurate performance and a safe life in service. Using cyclic symmetry, it's possible to simplify the modelling of the assembly to a single fan blade or cluster of blades and their associated segment of the disc. Using this approach saves analysis time and cost by reducing the finite element modelling down to a manageable problem size and without compromising the quality of results for the customer. Finite element analysis software is used to set up the model and simulate the behaviour of the assembly under flight conditions. By showing displaced shape results, assessment can be made of the shape changes across the aerodynamic surfaces. This assists with performing an unrun of the blades to define their unloaded manufacturing geometry. When run up to their design point operating condition, the shape of the aerofoil surfaces change to meet optimum aerodynamic performance. Full assembly results can be used to monitor the behaviour of each blade. This is particularly useful under dynamic vibration, whereby modal frequencies occur across the fan set assembly. Individual blade stresses and natural frequencies are calculated, ensuring the assembly meets satisfactory fatigue life requirements without undesirable vibration characteristics. This can be especially critical around the blade root, where peak stresses often occur. These simulation results can be used to position strain gauge instrumentation, helping to monitor the running of the assembly and provide an additional safety measure. Thank you for watching. For further information, please refer to the Frewer Engineering website and follow us on LinkedIn.